Welcome to the High-Rise Exam Construction Workshop. I'm your chief architect for today, and we are diving deep into what is arguably one of the most highly requested, high-tariff topics out there. Section 6.3 of the Cambridge AS and A-Level Mathematics 9709 syllabus. We're talking about continuous random variables, specifically engineering the mean and variance from probability density functions, or PDFs. Now, whenever we tackle a complex past paper question, I see two types of builders out there. First, we have Alex. Alex is the kind of student who stocks way too many unorganized factual bricks, just dumping formulas onto the page without any real structural logic. Then we have Sam. Sam focuses entirely on flashy exterior design, maybe writing out a really neat final answer, but completely forgets the load-bearing sentence structures and mathematical working needed to hold it all up. Neither approach is going to survive the stress test of a Cambridge exam. So today, we're fixing that.
This bold promise right here comes straight from a senior examiner, and it completely shifts our perspective. You hear the phrase easy marks, and honestly, it can be a little frustrating if you've been losing them, right? But what they're telling us is that the foundational cracks in both Alex and Sam's approaches are entirely preventable. If you actually understand the mechanics behind the mark scheme, how to lay down an unshakable thesis foundation and erect load-bearing arguments, you are going to secure every single one of those marks.
So here is our architectural schematic for today's workshop. First, the core exam principles. Second, the method mark strategy. Third, top examiner warnings. And finally, deconstruct, solve, evaluate. Let's get building.
Section 1, the core exam principles, where we focus on laying the theoretical architecture.
Okay, let's map out our structural skeleton on a digital grid overlay. To build a top-tier answer, you have to perfectly balance your assessment objectives. We're talking about balancing AO1, basic knowledge, with AO2 and AO3, which test your analytical depth and problem solving. This is exactly where our builder Alex goes wrong. Alex tries to cover everything with superficial breadth, memorizing the expected value formula but having no idea what it actually represents. Cambridge examiners don't want a flimsy, broad foundation. They demand analytical depth. They want to see that you truly understand how a probability density function maps to the real world and exactly why that variance formula behaves the way it does when you integrate it.
If you want your text blocks to survive rigorous marker reviews, your blueprint must incorporate these three elements. Think of precise definitions as your high-grade steel beams. Causal relationships are the bolts holding them together. For example, showing the direct cause and effect between the integration limits you choose and the specific context of the random variable. And cross-topic connections? That's your reinforced concrete. Principal examiner reports explicitly state that candidates who connect Section 6.3 to their wider statistical knowledge absolutely dominate the grading scale.
Moving on to Section 2, the method mark strategy, proving why the process is infinitely more important than just the final answer. All right, pause the blueprint. It is time for a mid-workshop site inspection. Look, if you want to fortify your academic foundations and get weekly structural grade upgrades, you need to subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications. Seriously, hit that button. Okay, site inspection over. Let's resume. Imagine our builders, Alex and Sam, are mid-paragraph and they hit an unexpected structural crack. They mess up a negative sign during integration. It happens, right? But this 5-step standardized sequence is your structural matrix, your ultimate safety net. It's like the Peel method for essay writing, but for complex math. If you clearly identify the PDF, logically apply the expected value formula, and execute the analysis step by step, the examiner can still award you crucial method marks even if the final calculation cracks.
Now, to completely weld your evidence to your analysis flawlessly, your presentation has to be pristine. Sam often fails here by just throwing a naked number at the bottom of the page. You cannot make the examiner hunt for your structural integrity. Use the correct terminology. Write out E of x for the mean, or var of x for the variance. Lay your algebraic steps out vertically so the load transfers naturally down the page. Clear annotation isn't just for your benefit. It is a literal roadmap you draw for the person stress testing your exam paper.
Let's talk about extracting your raw materials. Often, these continuous random variable questions aren't just bare equations. They come wrapped up in a real-world context. It might be a PDF modeling the lifespan of an electrical component in thousands of hours. You have to actively pull the correct mathematical boundaries out of that text. If the text says the component fails between 1 and 4,000 hours, those are the limits for your definite integral. Extracting that primary metric correctly is the first step to pouring a solid concrete foundation.
Let's pivot to Section 3,
Top examiner warnings, where we learn how to avoid the classic trapdoors. It is time for a live audience diagnostic. According to years of examiner reports, there are exactly 3 major structural flaws that continually cause a total marks drop for students. I want you to mentally prep yourself to spot them.
If we put a 60-second visual countdown timer on a sample student paper, these are the 3 things you'd be scanning for. Number 1, using the wrong approach. You would be shocked how many students try to force discrete probability formulas onto a continuous probability density function. It's like trying to use wood glue on steel. It just doesn't work. Number 2 is sloppy presentation that obscures the logic. And number 3 is the absolute biggest structural gap of them all.
Test number 2. Identify the flaw. Look at the difference between a generic answer and a context-specific one. This right here is what separates an average builder from a master architect. If the question asks you to interpret the mean you just calculated and the variable x represents hours of battery life, your answer cannot just be, the expected value is 12. That is a generic response, and it will cause a structural collapse in your marks. Every single point must be welded to the scenario. You must say, the expected battery life is 12 hours. It sounds like a tiny detail, but examiners penalize this omission relentlessly.
Finally, Section 4, deconstruct, solve, evaluate. This is the ultimate problem-solving formula.
Okay, team, let's do our final build inspection. When you read a completed, flawless response, it always follows what I call the 3 rules of equation engineering. First, deconstruct. Identify your given PDF and extract your limits. Second, solve. Break the integration into logical steps. Remember, variance is the integral of x squared times f of x minus the mean squared. Execute that with crystal clear notation. And third, evaluate. This is where you stress test your own work before the examiner does. Check for reasonableness.
Part of that evaluation rule means asking yourself this critical question. Let's do a quick structural diagnostic. What if you finish your massive variance calculation and the final number is negative? Does a negative variance make sense? Absolutely not. Variance measures spread. It has to be positive. If you get a negative number, your evaluation step just caught a massive structural failure before the building collapsed. Go back, check your integral, check if you forgot to square the mean. Being aware of these elements proves to the examiner that you are a top-tier candidate.
So here's my challenge to you. Apply this precise, deconstruct, solve, evaluate framework to your very next past paper question. Stay strictly away from Alex and Sam's bad habits. Now, for our final call to action. If this workshop helped you upgrade your blueprint, make sure you subscribe to Ace the Exams at Ace the Exams, click the notification bell so you never miss a site inspection, and leave a comment down below with your specific subject and level. I'll leave you with one final provocative thought. If your probability density function model completely breaks down at the extreme upper and lower limits of a real-world scenario, how mathematically sound was your expected value to begin with? Think about that during your next practice session. Keep engineering those flawless answers, and I will see you in the next workshop.